Welcome to the world of Python dictionaries. Imagine having a real dictionary where you can instantly find any word's definition. Python dictionaries work similarly, they store key-value pairs for lightning-fast lookups. Whether you are mapping student names to grades, storing configuration settings, or building complex data relationships, dictionaries are your gateway to efficient data management. Let's unlock their power. Dictionaries are Python's built-in mapping type. Unlike lists that use numerical indices, dictionaries use meaningful keys to access values. Think of them as real-world dictionaries where words are keys and definitions are values. In a physical dictionary, you look up a word to find its meaning. Python dictionaries work the same way, you provide a key and get back the associated value. In Python, we create dictionaries using curly braces with key-value pairs separated by colons. Here, student names are keys, and their grades are values. Let's explore the various ways to create dictionaries in Python. Dictionaries can be created with curly braces or the dict constructor. Keys and values can be different data types, strings, numbers, booleans, even lists. Python offers several other ways to create dictionaries efficiently. You can create dictionaries from tuples. Use keyword arguments with dict. Use dictionary comprehensions for dynamic creation. Or combine two lists with zip. Let's see how to work with dictionary data, accessing, adding, and modifying values. Here's a sample dictionary with personal information. We access values using square brackets with the key. This gives us instant access to the associated value. Let's explore the essential operations for working with dictionaries. Dictionary operations are intuitive and powerful. Use square brackets for direct access, or get method for safe access with defaults. Add or update values by assignment. Remove values with pop or del. Check membership with in operator. Dictionaries come with powerful built-in methods. Let's explore the most useful ones. Dictionary views provide dynamic access to dictionary data. The get method safely retrieves values with optional defaults. setDefault gets a value or sets it if missing. Update merges multiple dictionaries efficiently. Dictionaries achieve their incredible speed through hash tables. Let's understand what makes them so efficient. Hash tables use a hash function to convert keys into array indices. This allows direct access to values in constant time, regardless of dictionary size. When we look up Alice, Python hashes the key to find the exact storage location. Let's explore how dictionaries solve real-world problems across different domains. Dictionaries excel at counting and grouping data. We can count word frequencies, analyze sales by category, or group any data by common attributes. Specialized dictionary types like counter and default dict make these tasks even easier. Dictionaries are perfect for caching expensive operations. Memoization stores function results to avoid recalculation. API response caching reduces network calls. The key-value structure makes lookups instantaneous. Dictionaries excel at managing hierarchical configuration data. They can store database settings, API configurations, feature flags, and user preferences. The nested structure mirrors real-world configuration files like JSON, making them intuitive to work with. Dictionary comprehensions provide an elegant way to create dictionaries from other iterables. They're concise, readable, and often faster than traditional loops. Dictionary comprehensions create dictionaries in a single, readable line. You can square numbers, flip key-value pairs, filter with conditions, process text data, or create complex nested structures. They're particularly useful for data transformations and quick dictionary generation. Real-world data is often hierarchical. Nested dictionaries handle complex data structures like JSON APIs, configuration files, and multidimensional data. Here's a nested dictionary representing employee data with personal and work information. Notice how the structure naturally organizes related data into logical groups. Accessing nested data requires chaining key lookups. For safety, use helper functions that handle missing keys gracefully. You can update nested values by navigating the hierarchy and add new nested structures as needed. Dictionary views provide dynamic access to keys, values, and items. Understanding how to iterate efficiently is crucial for data processing. Dictionary views are live connections to the data. They automatically reflect changes. You can iterate over keys, values, or key-value pairs efficiently. Sorting dictionaries requires the sorted function with key parameters for custom ordering. Let's explore common mistakes when working with dictionaries and learn best practices to write robust, efficient code. Common pitfalls include key errors from missing keys and modifying dictionaries during iteration. Best practices include using GET for safe access, checking membership with IN, and collecting items to modify before changing the dictionary structure. Python offers several advanced dictionary variants and features for specialized use cases. Advanced dictionary features include default dict for automatic defaults, counter for specialized counting, and chain map for combining multiple dictionaries with precedence. These tools make complex data operations more efficient and readable. Understanding dictionary performance helps you write faster, more efficient code. Dictionary performance optimization involves using membership testing with IN, leveraging GET to avoid exceptions, using setDefault for conditional updates, preferring dictionary comprehensions, using default dict to avoid repeated checks, and iterating efficiently with items. Here's a practical guide to help you decide when dictionaries are the right choice. The key question is whether you need to map keys to values. If yes, dictionaries are perfect. They excel at configuration settings, database records, caching, counting, lookup tables, and handling JSON-like data structures. Let's summarize the essential concepts that make you a dictionary expert. Key concepts include understanding key-value pairs, hash table performance, and immutable keys. Essential methods are GET for safe access, iteration methods for processing data, update for merging, and POP for removal. Performance tips include using membership testing, preferring GET over exceptions, and leveraging dictionary comprehensions. Dictionaries are truly your data's best friend. They're fast with O1 lookups, flexible with any key-value relationships, and fundamental to Python programming. From configuration management to data caching to complex data structures, dictionaries provide the foundation for efficient, readable code. Master dictionaries, and you'll master Python data handling. Thank you for joining this comprehensive exploration of Python dictionaries. You now understand their power, performance, and practical applications. Practice with real projects. Experiment with advanced features. And remember, when you need fast key-value lookups, dictionaries are your go-to solution. Keep coding, keep learning, and keep building amazing things with Python.